Hello, everyone. You're welcome once again to my YouTube channel, Messed Up Mentors. This is Python for All. In today's series, we'll dive straight into Object-Oriented Programming Part 4. Here we will look at multiple inheritance, which is a continuation of our previous video, OOP Part 3. But specifically, we'll talk about non-cooperative classes or non-cooperative class in this video. So I will continue from the example 3. We stopped at example 2. So in example 3 here, I want to demonstrate again in multiple inheritance. So first I have a problem I want to solve here, which has to involve the force of attraction between two masses, that's gravitational force, and how to adapt that to compute electric force. So first we import the required packages, which we have already done here, and I define a class known as gravity, and then passing the masses m1, m2 as input argument. The constant g is fixed, so I have self.g fixed. You can either make it an instance variable here or a class variable. It doesn't really matter, but I prefer to keep it here. And then also initialize M1 and M2, the two masses. And then define force, okay, which takes the distance between the two masses. And I return self.g multiplied by self.m, self.m1, M2 divided by the square of the distance of separation. And then I have another method implemented there, which is to visualize. Okay, so I take an interval between 2 points, vary the distances between two values, start value and the stop value, and a fixed number of points of 100 by default, which can be changed. And then I call np.linspace to create linearly spaced value or vector between the start and the stop and the number of points. And then f of underscore g calls self.force of r. In other words, I'm calling this method by using the self method to call that. And then the next thing you see here is plotting the force of gravity with the distance. And then the color is by default red. So this is just the illustration of what happens under the what is happening in the visualize method. So run this, and next here I'll just put a call to the gravity and pass in the mass of the sun and the earth. Okay, and then the distance between that 6.6 exponent 6, and then print the gravitational force in Newton to 4.4 exponential scientific notation form. So if we run this, it gives us the gravitational force is this. You can see the gravitational force pull between the earth and the sun. Okay, and then we can visualize this by taking two slides between 5 exponent 5 this at this distance, okay, about 50 million, and between 6.6 exponent 6. If we run this visualize, it tells us how you can see the distance. Okay, this is just a plot showing us the gravitational force against the distance, right? So as you decrease the distance, you experience, an increase in the gravitational pull. So the next I will do here is to call. Now I want to implement Coulomb's law to compute the force of attraction between two charges, either like or unlike charges. So here I define a class Coulomb that inherits from gravity. And the only thing I do is just call the constructor, the instance method, Q1 and Q2. The constant G, the class Coulomb's law will inherit everything from this parent class, the false, the visualize. Okay, all I need to do is to call super. So by calling super here, I simply pass in the two inputs that the gravity class takes, which is what M1, M2, but in this case, it's replaced with Q1 and Q2. By doing this, I can simply call my column, this is small letter C, column law, and pass in two charges, okay, 1 times 10 to the minus 6 and minus 2 times 10 to the minus 6. Then I can print the electric force by calling C dot force and passing the distance between these two forces. okay, approximated to force significant figure in Newton. Then I call C dot what visualize. In the case of force, what do we have? If we run this, you see we have the electric force, it's minus 1 point. It show, of course, the negative sign is showing us the direction of the force, okay, of the electric force between the two charges, and we can see how the force and the distance of separation vary. It is, opposite that of the gravitational pull. So this is visualized. Although I did not implement the method visualize and force in the Coulomb's law, but by inheritance, okay, I've inherited that from the gravity class. So having said this, we'll move to the next example here. In this example, we'll precisely look at the non-cooperative class, which is the core subject of the matter. So here we have a class of roots. Then in root, I don't have any constructor. I have a method, draw, and then here I have an assert statement. Assert not has attributes super and draw. Don't go into the rudimentary of this. As we go down, I'll explain what is happening there. There's I have a class of shape that inherits from roots. Okay, and there I have the constructor. It takes a shape name and keyword arguments. Okay, that's what it means. Keyword argument or multiple name argument, keyword argument. So you have self dot shape name is shape, and then super dot init we initialize the keyword argument by calling super, because super calls root implicitly without explicit call to root. So that's what super is doing here, and it takes in keyword argument. And then I will now implement a draw method. By implementing this draw method, I've overwritten the draw method from the root class. So, and that brings setting shape to self.name and then super dot draw. Now, this alone is polymorphic. This alone we call the draw method in the super class. I overrode that, but I'm still making a call to that super class. The next, I have a class of colored shape, and here I have shape again coming in. I'm now inheriting from shape. Can you see shape from root, color shape from shape, and then I'll pass in color and keyword argument. Now this has to pass in this double asterisk keyword argument because already the class we're inheriting from has that double, so you have to do that, to avoid attributes error. So self.color is color and super.init, same again like you did, keyword argument. And then here I implement again another draw method, overriding that, but setting color to color, and I call the super. Now this super.draw, we call the draw method here, and this super.draw in root, we call the draw method in the parent class roots. So let's see what happens if we run this code. So we run this code, and then let's define a shape S that calls, let's shape a circle and do S.draw. What do we have? Setting shape to what? To circle. You see? Now, setting shape to circle. So where do we have it? Shape, what do we have? Setting what? Shape to what? To circle. And then let's do a colored shape and then passing color green and shape name rectangle. Now we're doing colored name. Now we have passed in a named argument here. How are we able to do that? Because of this double asterisk KW here. So it can allows us to pass in, a named argument or a dictionary. In there. So let's run this, and then by the time we call cs.draw, what do we have? You see, it puts a call to what? To the draw method in color. You see, setting color to green. Okay, that's a draw method in color, in a color shape, right? Setting color to green. And this puts a call to what now? To the draw method in what? In shape. And what's that? Setting shape to what? To rectangle. The shape class puts a call to this, and what that is asking you is just to assert if the super class actually has the draw method, which indeed has. So that's why it's not thrown up error. If it doesn't have that method, it throws up that error. So that's actually what that is saying there. That's why it's not seen printed out here. So let's look at the shape method resolution order. If we run this, you can see shape, okay, takes from root and root from the uh, main class object. In the same way, let's look at color, shape, method, resolution, order. You see color, shape, root, and object. Now, let's assume we want to have a class of point. You will notice that this class of points actually it does not share any common attribute with root, shape, or color. So this class is actually not cooperative with those previous classes. But for we to associate this class point with those classes, we have to write an adapter class. So first of all, define the class of point that takes 2 points, x and y, and then draw, simply say drawing at position self.x, self.y. But now we define another class which is known as a point adapter, and that inherits from roots. The constructor takes x and y and what? Keyword arguments. And then here we have self.point. Here we have what? Initialized the point class. And then we call the super method again. Why? Because we are inheriting from what? From the root class. So having done that, and then we implement our draw method. Our draw method here is calling the draw method in point, which is self.point.draw here, okay, and then calling the draw method in the superclass. So that if we run this, and then we can now have, okay, the reason of making this adapter class is that we want to have a point colored shape. And so point color shape class will now inherit from colored shape and from point adapter. Mind you, point adapter inherits from root, but also is calling the point class, which is a non-cooperative class. It's a bit complex, but the idea of trying to associate the point class with the colored shape, and shape takes from color shape takes from shape, and shape takes from roots, is to have an adapter class. So that, and here we don't implement anything. All this class does is to inherit from the two classes here, colored shape and point adapter. So that's what we have passed. And then now I call a point colored shape. Color is brown, shape name is this, I'm passing the point, and then call a draw method on it. If we run that, what do we have? First of all, it calls the draw method in color shape, which is setting color to brown, setting shape to square, and then implement the draw method in the point class. So this is just the hierarchy. If we check the method resolution order, what do we have? It returns all the order of the call. What is it? Point, color shape, inheriting from color shape, inheriting from shape, inheriting from point adapter, inheriting from root, and finally from the base class. Now, we can also pass in a dictionary and unpack it as input argument to point color shape. Here, so we have here we have the dictionary of color. Color is red, the X is 6, Y is 5, shape name is triangle, and then we unpack it by this double asterisk and then call a draw method on it. And what do we have? Returns the result setting color to red, shape to triangle, and drawing position at 6, 5. With this, we have come to the end of today's video. If you find anything a little bit confusing, please leave it in the comment section. If you have any further questions you want to ask, also drop it in the comment section. I will leave a link to this notebook in the description. Please like this video, share this video, and also subscribe to my channel if you are just watching and you have not subscribed to my YouTube channel. I will see you in my next video, which will be the part 5, where I will continue our discussion on object-oriented programming and specifically discuss another concept in OOP, which is known as mixing.